We are starting the last chapter. Our time together has gone very fast, and the last chapter is just a review from your algebra days on logs. We're going to talk about the connection between logarithmic and exponential form. We're going to solve some log equations. We're going to be using logs to simplify, and then we're also going to be doing some growth and decay problems. That'll be our last section. Today is just like the basics, kind of remembering how logs work. And so the connection that you need to remember, or how you can go from a log to a power. The log has a base. It's got a small little number next to it. That's a small number. That is the base of the exponent. And then the answer to a log is the power. And what you take the log of is the answer to the exponent. So they're very closely related. In fact, they're inverses of each other. If I could sketch the graph of an exponential growth equation, its log is its inverse. And I don't know if you remember back in the day, so long ago, we talked about inverse. Inverse equations reflect over the line y equals x. So this would be, let's say I said this is y equals 2 to the x power. This would be the inverse function. That would be y equals, so y inverse, I could say y, remember we put that little -1. Y inverse would be the log base 2 of x. That's where you flip-flop your domain and your range in an inverse, and so they are inverses of each other, where you would flip-flop your domain and your range. Well, let's start by just writing from log form to exponential form. Remember that little number there becomes the base, the answer is the power, and then the number that's left goes on the other side. Sometimes it's easier to see it when it's in numbers, because it makes a lot more sense. Log base 7 of 49 is 2. 7 squared is 49 would be the translation for that one. Log base 11/8 of u is v. 11/8 raised to the v power equals u. And our last one, just another quick practice, 12 to the r is 120. Just as we can write from log to exponential, we can also write exponential to log. You just have to kind of remember where the pieces go. The base of the power of the exponential form becomes the base of the log. The power is always the answer. And then the other thing that's left is what I'm taking the log of. So I have a log base 5 of 25 is 2, because 5 squared is 25. The log base 17 of b is a. Again, the thing to remember is that the power is always the answer in the log. And that's kind of why they invented it. John Napier kind of worked with logs, and he did it because that way we could find a power that isn't maybe necessarily an exact value. So like if I had 2 to the x power equals 10, well, I know 2 squared is 4, and 2 to the third is 8, and 2 to the fourth is 16. But what would be 10? Well, I know it's got to be something between 3 and 4, because again, 2 to the third is 8, and 2 to the fourth is 16. So it's some number between 3 and 4, but if I put it in log form, I am able to find that. Log base 2 of 10 will give me that power. So that's kind of why we use them, or how we use them, a way that we use them. And then we also use them in exponential growth and decay. But anyways, I guess I'm just getting chatty. Here we go. Log base n of 169 is m. Power is the answer to the log. So let's take that and evaluate some log expressions. And when we do that, what we have to do is talk ourselves through it. So I have to think of what power, this is what I'm trying to answer, what power would I put on 6 to get 216? And you may have to play around with that. Maybe you have to kind of think, okay, 6 times 6, 6 times 6 is 36. If I multiply by another 6, then I get 216. So I add 1, 2, 3 6s in there. So that's the power that I put on it. Therefore, the answer to this expression is 3. I have to be aware that sometimes I'm going to have fractions. And if I have fractions involved, I just have to kind of think through it. Remember what puts this in the denominator, or let's write it this way, the way I did the other one. Some power on 2 would give me 1/32. Well, to put it in the denominator, I know that power has to be a negative number. And then I have to figure out what power do I put on 2 to get 32. Well, 2 times 2 times 2 times 2, and I can kind of work my way through it. It actually ends up being 2 to the 5th power. So 2 to the 5th power is 32. What makes it a fraction is a negative. Therefore, the value of this one is -5. I have another one of those. I just did this problem above, okay? Log base 6 of 216 was 3. Log base 6 of what would make it a fraction? Well, I already know to get 216 I need to raise 6 to the 3rd power, but to make it a fraction I would need to make it a -3. What power do I put on 32 in order to get 2? Now this one's a little bit weird because 32 raised to some power equals 2. Not 2 raised to some power equals 32. Basically, I have to get back to that. Again, I can use the problem above to help me through that. Because just like these powers work with the whole numbers, 2 to the 5th power is 32. That means the 5th root of 32 is 2. And so how do we do a 5th root? A 5th root of 32 is 2. How do I translate that to a power? That's 32 to the 1/5 power. So what does this equal? 1/5 would be my answer for that. So I can have negative, I can have fractions. Let's do another one like that. What power do I put on 16 to get 2? That means 16 raised to some power is 2. Well, I know the 4th root of 16 is 2. So that means 16 to the 1/4 must be 2. Therefore, my answer to this problem is 1/4. Be aware, because sometimes I'm going to end up with negative values, and when I think about it, 2 to some power equals -16. Can I ever multiply 2 by any number of times and end up with a negative value? If I do 2 times 2, I get 4, times 2, I get 8, times 2, I get 16, times 2, I get 32. It doesn't matter what I'm doing, I keep getting 2. It's always going to be a positive value. And that means that this is undefined at that location. There's no answer because there's no way to take a positive base and make it negative, no matter what power I put on it. If I put a negative power on it, keep in mind, the negative power makes it a fraction. It doesn't make the value negative. So I have an undefined situation there. All right, so now the last section that we're going to do is what happens if I have a scenario where I can't figure it out. 6 to some power equals 26. Well, 6 to the 1st is 6, and 6 to the 2nd is 36. Somewhere in between 1 and 2 is going to give me a decimal or whatever, 1 point something will put as a power on 6 will give me 26 as the value. struggling saying that a little bit, but I hope you get what I'm saying. And so I need to figure that out. Now, some of you guys have calculators that all you have to do is plug that in. But if you don't have a calculator, most of us have calculators that have two logs on it. They have a log key, and above that log key is 10 raised to the x power, or we have a natural log key, which is ln, and above that is e to the x power. So you need to locate one of these two keys on your calculator, because you can use these to figure this out. Log with no number after it is always a base 10. But if it has this little base on it, then I have to use it. I can't just assume that I can just use this log key and hit it, because that's with a base 10. So the keystrokes are, I can use either one of these. I do log of 26 divided by log of 6. I have to make sure that I close my parentheses on those before I hit equals. Log of 26 divided by log of 6. Or I could do the natural log as well. But when I plug that in, I go on mine, so you log and raised above it is 10 to the x. ln is the other one that I could use, so I do log of 26 divided by log of 6. Close my parentheses on those, and 1.818, which is exactly what I thought. It was going to be something between 1 and 2, and so this is 1.818. So that means if I take 6 and raise it to the 1.818 power, I should get something very close to, oops, I hit it wrong. My calculator sometimes has sticky keys. So if I take 6 raised to the 1.818 power, I should get something really close to 26. Now, of course, it's going to be off because I round it a little bit. The more accurate I keep it, the closer to 26 I'm going to get. If my log problem is ln, that stands for the natural log, it shows up as capital ln on my calculator, then I can just plug that in, ln 60, and it'll get my answer, 4.094. So this is equal to 4.094. Well, ln, what is it? ln is a log with a base of e, the number e. The number e is like the number pi, kind of. I mean, it's not the same as the number pi, but it's similar. It's a number that's out there, a non-repeating, non-terminating decimal, and we use it in growth and decay problems. And so if I were going to evaluate this problem with my calculator using the log key like I did the last one, I would have to do the log of 60, close my parenthesis, divided by the log of e. So I'm going to have to do second e to the first power because it needs a power on it. So the log of e is a number, and that will give me my value again, 4.094. So e, the number itself, second e, is about 2.71. E to the first power gives me about 2.71828, blah, 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 blah. But we'll get more into that when we get into our growth and decay. Just like if I have an ln problem in number 17, if I just have a straight log problem, I can just plug it in my calculator using the straight log key. If you don't have a straight log key and you need to put a base on there, keep in mind that the base, if you don't see it, is 10. And so I just do the log of 46, and I get 1.662, so this is about 1.662. Again, remember, 275, blah, blah, blah. Okay, again, what this means is if I take 10 and raise it to the 1.66275 power, I put a few more on that, I should get really close to 46. Again, it's a little off because I rounded, but it's getting closer, 45.999. If I get even more decimals, I'll start getting 45.9999999, depending on how many decimals I put in. All right, so I've got one more that's just like the first one. Again, if I need to evaluate this and I don't have a calculator that allows me to plug that in, I have to do the log of 57 and the parenthesis divided by the log of 5, and the parenthesis. It's log of the big number divided by the log of the base. So this is 2.512 again. This means that if I take 5 raised to the 2.512 power, I will get something really close to 57. And so that's it for today. You can work on your homework. 13.1, evens or odds. And also it'd be a good idea to start working on, or keep working on your review. I will see you in class tomorrow. Hope all is well.